So when I saw this problem, what I thought was that, oh, we got three numbers, right? But we're trying to find the most expensive, the largest item that cannot be expressed using those numbers. So we're trying to find a value that cannot, the biggest value that cannot be expressed in this Diophantine equation, right? So this is a useful theory for solving those kind of problems. It's called chicken and McNugget theorem, which states that when you deal with two coprime numbers, so A and B are coprime, then the largest number that cannot be expressed as a sum of multiples of those two AB is gonna be AB minus A plus B. Largest number that cannot be expressed in terms of A and B. So to give you an idea of how this looks like, let's think of 3 and 7. What's the largest number that cannot be expressed as a multiple or as in whatever way that you can do with 3 and 7? So for example, 12 I can represent it as 3 times 4, right? 13 I can represent this as 3 times 2 plus 7, right? And then so 14. So what's it? We're trying to find the biggest number that cannot be expressed in terms of 3 and 7. And it's simple when you use chicken and McNugget theorem. It's just going to be 3 times 7 minus 3 minus 7 equals 13. Now, can 13 be represented by any 3 or 7? Well, you try for ages and you'll find out that nothing exists. So this is how you use chicken and McNugget theorem. But in this case, note that we have 6, 10, 15. So firstly, we got three numbers, right? But the thing is that, okay, so note that 6 and 10 are even numbers and 15 is odd. So with let's say you only have 6 and 10. Can you represent any odd number? No. With this equation, you'll not be able to represent any odd number. Because why? It's just going to be even number plus even number, which is going to result in even number anyways. So that's why we have this 15 to represent odd numbers. You just add 15 and you represent odd number as well. So let's try to apply chicken and McNugget theorem in 6 and 10. But note that 6 and 10 are not coprime. So when I thought of doing this, I try to think of, well, let's just divide it by its GCD. Well, GCD is 2, right? So we divide it by that. We get 3 and 5, which are coprime. And according to chicken and McNugget theorem, the largest number that cannot be expressed with 3 and 5, it's going to be 15 negative 8, so 7. So note that 7 cannot be expressed in terms of 3 and 5. And now, since GCD was 2, I just multiply 2 to get 14. So 14 is the largest number that cannot be largest even number that cannot be represented by 6 and 10. And because we're only dealing with even numbers when we're dealing with 6 and 10, we're basically saying that 16 can be represented as 6 plus 10. 18 can be represented as 6 times 3. 20 can be represented as 10 times 2. Okay, the list goes on. So 14 is the largest number that cannot be expressed in terms of 6 and 10, right? Now, we'll just add 15 to it. 29, 31, 33, 20 plus 15, 35, and the list goes on. So, and in between those odd numbers, 32 can be represented, because it's an even number, again, by 6 times 2 plus 10 times 2, so 20 plus 12, right? And the 34 can also be represented. Why? It's just going to be, because it's a cycle, if you notice. It's just going to be 18 plus 16, but those two numbers are already represented, can be already represented by 6 and 10. So this will also be able to represent it by 6 and 10. So the largest number that cannot be expressed in all 6, 10, and 15 will be 29. Because 31 can be represented by 16 plus 15, right? And 16 is already 6 plus 10. So 29 will be the biggest number. And 30, if you ask me, that's just 6 times 5. So we're basically excluding even numbers. We don't care about even numbers. Why? Because we already know it can be expressed in terms of 6 and 10 according to Chicken and McNugget theorem, right? So we're just trying to see that what's the biggest odd number that cannot be expressed using 6, 10, 15, and that's just going to be 29. So the answer to this problem is 29.